Hi, this is Herb of the Dr. Vax channel, and today we're going to discuss whether I should break up with an old friend. A friend I've had for about 2.5 years. You see, the very first 3D printer that I own, that I still own, is a Prusa i3 MK3. And that printer shipped with a Prusa edition of Slick 3R. The Prusa edition of Slick 3R 2.5 years ago was pretty hard to use. Wasn't great. The user interface was awkward. So I went out and I bought a copy of Simplify 3D. I didn't find it very simple. But I used them for a while until I bought my next 3D printer, which was a Creality 3D printer. And they recommended I try Cura. Cura felt a little easier to use to me, and what was most important is Cura at the time was already starting to evolve rapidly, to be upgraded often. So for a while I used the PrusaSlicer and the Cura Slicer, but starting about, a year and a half, 2 years ago, I started using the Cura Slicer almost exclusively. I know Cura really well. If I see something on a print like these thick layer lines at the top of this round surface, I know what to do. I see bumps in that print, I know what to do. But I recently tried PrusaSlicer version 2.3 because they announced with a lot of fanfare that they now support, fully support it seems, non-Prusa 3D printers. And they have profiles for all the Creality printers as an example. So I loaded up PrusaSlicer 2.3 and tried it out on my Ender 3 version 2. Stay tuned and I'll share with you what I learned. So let's learn something together. Folks, if this is the first Dr. Vax video you're watching, do me a favor, subscribe to the channel. It helps me out with YouTube. And if you enjoy the video, share it with your friends and click on that bell so you're notified when new videos become available. There's no cost to you to subscribe to a YouTube channel, but it helps us creators get some attention from YouTube. Today's video is not going to be a tutorial, a point-and-click tutorial on PrusaSlicer. I chose to use fixed slide images, pictures of the various screens to make the video move along a little bit quicker, so I could cover more material in a shorter period of time. So let's start with the fundamental question. Why would I even consider leaving my old friend Cura? Many of us, when we have a tool that we use that we really like, we don't want to change. You know, I'm an old enough guy to remember when there were word processors other than Microsoft Word. I was a Word Perfect guy. Some of you might also remember that. I was very hesitant to switch because I knew how to use Word Perfect. And Microsoft knew, it was different. Everyone said it was wonderful, but for me, it wasn't the word processor I was used to. PrusaSlicer, in spite of the fact that I first started with it, seems the same way. So let's look at the screen together, and I'll quickly go through some of the things I find so very intriguing and why I'm going to really start using it every day to give it a good shot. I'll be going through these features one by one in more detail to explain them to you. First, an overview. Paint on custom supports and scene placement. Yes, there are a number of ways to do custom supports in Cura. There's automated supports built in. There are plugins for a variety of custom supports. There's the ability to do support blockers. And you can tell Cura where to put a seam. The paint on concept as implemented in Prusa is brilliant. We'll talk more about it. Variable layer height is another feature that is coming to Cura. It's an experimental feature now where it varies the layer height based on the shape of the model, which is really important because it's really for round areas like this that you want smaller layers, and for flatter areas you can use larger layers. We'll go into more detail. Once again, PrusaSlicer, the implementation is brilliant. It's really easy to use and you have complete control. We'll look at the overall UI and the print time analysis, which is very, very nice. But then one of the features that's most interesting is when you have a flat surface, even a small flat surface like this on the top of a model, Prusa has introduced a new type of fill called Monotonic Fill, which is rather magical. It makes the top surfaces of your prints just really, really nice and smooth without any artifacts. For many printers that support the Marlin M600 feature, Prusa might have the easiest to use filament change implementation that I've seen. MVS, or maximum volumetric speed, is a very interesting experimental advanced concept that we'll cover in some detail because I think it's going to overall change 3D printing. And then we have to talk about quality. And one of the things that you do get with a Prusa machine is great documentation. So how do you get started with PrusaSlicer? If you go into Google and you just Google PrusaSlicer one word, it'll take you to a list of choices. The top choice that comes up most of the time is the actual Prusa page. You'll see the Prusa page on the upper left of this slide. Now, I don't recommend you use the installations that are listed on the bottom half of that page. Those install a bunch of stuff that you won't need if you don't have a Prusa printer. Instead, there's a link on that page to the GitHub repository for PrusaSlicer, and that's the version I recommend you go to. So if you go to the GitHub repository and you download the most recent release for your particular operating system, I think that's the best way to go. Then install it the way you install any software on your computer. One of the things you'll notice when you start up PrusaSlicer, and it will happen often when you start up PrusaSlicer, is it will give you an option to update the underlying configuration files. You'll notice on this screen, one of the updates that came up yesterday to me was an update for Creality printers. So Prusa is not only updating their configuration for their own printers, they're now updating the configurations for some of the third-party, from their point of view, printers that are included. To get started, you want to go to the configuration menu item on the top and click on Configuration Assistant. And then basically, you just follow the instructions. The first thing you need to know is click on Other Vendors. Don't click on Custom Printer. Click on Other Vendors. You'll see the vendors that are currently supported with built-in profiles. Creality is one of those. Click on Creality, then click on Next. That'll take you to a page that looks like this, and you'll see a whole bunch of Creality printers. Pick your particular model or the one that's closest to the model. Click on Next and follow the instructions. You'll be given an option to load filament profiles, a couple other choices. Make the obvious choices, and you're ready to go. Now, let's take a look at the user interface because it's quite a bit different than Cura. On the right-hand side, you'll see three sections: Print Settings, Filament, and Printer. Print settings are basically your profile, your quality profile. That sets items such as layer height, fill, ... Filament is the type of filament you're going to be printing with, and if you have more than one printer installed, you'd select those under Printer. The gears next to those items do the same things as the tabs at the top of the page. So if you click on the gear next to Print Settings, it will go to the same section as Print Settings on the top, Filament the same section, Printer Settings the same section. The items on the left-hand side are used to manipulate the object on the screen. And if you mouse over those items, it will tell you what each of them are. And I'll be looking at a couple of those with you together as we go through some more advanced features. Now, what about print quality? Well, I printed a number of items, and I actually have P's and C's on the bottom of these. You probably can't see them, they're too small. With both Cura and Prusa, the exact same model using defaults, and they're very, very close. I did get a little more stringing, interestingly enough, with Cura, and the Prusa models printed faster. Now, I always thought my Prusa was faster just because of the direct extruder, and I think that's a lot of it. But I think maybe 10% of the speed increase is the actual PrusaSlicer. Overall, I would say the Prusa models might look a little bit better, but it's very close. Now, let's start talking about some of the features that are compelling enough that I'm willing to switch from my old friend Cura. The first is the paint on features. If you have a 3D model, and you can see in this picture a 3D model, where you would clearly need supports. Now, you could turn on auto supports on Cura or Prusa. It basically put auto supports pretty much everywhere. But if you know from experience that you only want them on some parts but not others, you click on the brush on the left-hand side, and then you paint the areas where you want support or you don't want support. So you, in essence, have the ability to say, enforce supports here and block supports here by painting them on the surfaces underneath. And then you can see in this screen capture where the support was added. So you'll notice there's a bluish purplish line or area under a couple of the arms. Those are areas that Prusa is telling me it thinks I need supports, but I either blocked them or didn't have automatic supports on, so they weren't added. Similarly, if you look at this picture, I'm telling Prusa with paint on seams where I want it to put the seam. It doesn't have to be the same on every layer. Fascinating ability to put the seams in different places by just painting them on your model. Now, in fact, I really can't find the seam on this model anyways. So Prusa did a really good job of hiding the seam. I'm not sure exactly where it hit it. There are some minor artifacts on this model, a little bit of bumps. I know I would change maximum resolution and deviation in Cura for that. There is a resolution setting in Prusa, which can also be used to impact the segment length, which should resolve those minor issues. But I can't find the seam anyways, so there was no need to paint on seams for that model. Now, let's look at this variable layer height feature. On the right, you'll see the pawn that's printed with a, I think it was a 0.20 layer height. On the left, you'll see the pawn that's printed with a 0.28 layer height for the majority of the pawn, and then 0.07, 0.08 for the top. It's beautiful. The two pawns printed in the same amount of time. By using a larger layer height on the left-hand pawn for the bottom, but smaller for the top, I was able to tune my print speed, my print time for this particular model. The way you set that up is when you click on the bar icon that you see highlighted on the top here. It has the white and the orange bars. Then on the left-hand side, by dragging that blue, purplish blue line to the right or the left, and there are instructions in the box below, you can vary the layer heights for the individual layers. So it's very graphical, it's very easy to see. You can then go into preview and look at it. It's a wonderful, wonderful, powerful feature. There is a variable layer height feature in Cura under experimental. It automatically adjusts the layer heights based on shape. And much like automated supports, you find as you're printing more advanced things, you want control over that. Prusa gives you that control. Now I'm going to talk about a feature that has a significant impact on quality if you have flat areas. Even a flat area like the flat areas on the top of these calibration cats. Now, this happens to be cubic infill. There are many different types of infill in Prusa, just as there are in Cura. I don't know that one does a better job than the other. But the problem with infill is when you have a complex infill below the top layer, even if you add multiple top layers, that infill has some impact on the quality of that top layer. So Prusa has introduced a very interesting concept that is even more sophisticated than a rectilinear infill, which is just straight lines. And they've said it's not just that we have straight lines in the infill, that it's a flat, consistent infill, but we also want the print head to move very, very consistently. We don't want it to print some here, then come back to here, because the smoother we make it, the better that top layer will be. So this is called Monotonic Infill. You can see it here. And with Prusa, you can set the infill pattern for the top and the bottom layers separately from the rest of your model. Now, there are other ways to modify many characteristics in your model at various layer heights. Prusa has a lot of capability there. This is a very simple thing, and this is now the default, to use monotonic infill for the top and the bottom. And here's what it looks like, and what Prusa says about it. It says it's basically the same as rectilinear infill with modified path planning. And the last sort of user feature I want to talk about is multicolor support. When you have a model loaded into Prusa, by dragging the arrows on the right-hand scroll bar, vertical scroll bar, and then clicking on the plus symbols, you can indicate to Prusa visually by layer, by height, exactly where you want to change filament. Each place where you tell Prusa to change filament, it's going to insert an M600 command into your G code. Now, if you're using a modern version of Marlin, let's say Marlin 2.0, most builds support M600. Unfortunately, the Ender 2 version 2 does not. And one of the reasons it doesn't is the screen on the new Ender 3 version 2 really doesn't have an information section, a place to say change filament now. But if you load standard Marlin 2 onto your Ender 3 version 2, which is really easy to do because there's a fantastic bootloader on the Ender 3 version 2, then you have M600 support and it works fine. Now there's no indication on the screen to change filament. You have to watch that the printhead moves away and the M600 command will cause the filament to unload. So when your filament unloads, you know it's time to put new filament in. And in fact, your printer will beep. But then when you do press the control knob on your Ender, it will continue printing. So the change color capability works fine. You just have to be a little more aware because there are no instructions on the front panel. Now, the last feature we're going to talk about is more of a theoretical concept that's experimental in the PrusaSlicer, but I think could really improve print quality and speed in the future. When you have a given hot end and extruder combination, the extruder pulls the filament off the reel, it pushes it into a heat zone that melts the filament. Your printer can only melt filament so fast. And if you try to print filament at a rate that's faster than its ability to melt filament, you're going to under extrude. Or you're going to try to force the filament in there of your extruder and cause jams. So PrusaSlicer has implemented a feature called Filament Max Volumetric Speed. And these are the recommended settings from Prusa for the i3 MK3 series of printers. What's important is that the slicer is now going to know how much filament it actually can extrude from that printer. And it will automatically adjust speed and other characteristics to make sure you stay in an acceptable extrusion window. Fascinating concept that I think has a lot of potential in the future. Now, there are a couple things I miss from Cura when I'm using the PrusaSlicer. For one thing, I know where everything is in Cura. I'm still looking around a bit in PrusaSlicer. There is a magnifying glass, which is a search icon you can click on, and then just like in Cura, you can type in, let's say, resolution, and it will tell you where to find that particular setting. Cura has the concept of an overall print speed. You set that, and then all the other print speeds for perimeters, for infill, for supports are calculated from that point forward. You can vary them, but you can change all of your print speeds pretty much at once by changing one number. You can't really do that in the PrusaSlicer. You can go to the front of your printer and change the overall speed multiplier on the front of your printer, but you can't do it in the slicer. I do like the combing controls in Cura. They make more sense to me than some of the don't cross perimeters controls and other controls in Prusa. I think the segment length control, that's the definition of what's the smallest segment that your slicer will generate, are easy to control in Cura, and the maximum deviation component of that is very, very nice. And then there are some experimental features such as fuzzy skin and other things that are interesting in Cura. But in total, I'm going to be a Prusa user for a lot of my prints now because it's come a long way and it's an excellent, excellent slicer. But that's not to say you can't use both. All they take is a little bit of space on your disk drive. Well, folks, I hope you learned something today. If you did, give me a thumbs up. If you want to talk about this, you can leave comments or you can go to forum.drvax.com and join and actually post images of prints, prints that were done on Cura, prints that were done on your PrusaSlicer, and talk about the results you're finding. Please subscribe to the channel, click the bell, and let's continue to learn things together.